We're going to look at some problems that look at the not so subtle connection between rational exponents and radical notation. So throughout the course so far, you guys have looked at things that say like 8 to the 1/3 or the third root of 8. And when we talked about both of these different ideas, we said, well, 8 to the 1/3 meant we were looking for a number that multiplied by itself this many times to make the 8. And we said the third root of 8 means we're looking for something that multiplies this many times to make 8. So these really are just two ways of asking the same question. One uses a rational exponent and the other one uses radical notation. And we really can just convert from one or the other. And depending on which we prefer or what the question is asking us to do, or in a multiple choice situation, how the answers look, we just want to be aware of that conversion. And it's as simple as recognizing that the denominator of a fraction in a rational exponent becomes the index of the radical on the radical. So if we're just going to look at this table down here and convert things from one form to the other, and of course with math, as always, if we're able to simplify what's left, we're going to go ahead and simplify what's left. So 27 to the 1/3 is an example of rational exponent, and the denominator is 3. So I could rewrite that with radical notation by saying the third root of 27. And regardless of how I'm looking at this, I know I'm looking for a number that multiplies by itself 3 times to give me 27. I can think of that number. That number is 3 times 3 is 9, times another 3 is 27. So it simplifies down to 3. If it doesn't simplify for something like a letter, z to the 1/4, look at that denominator of 4, and that 4 becomes the index of the radical. This doesn't simplify any further, but these are both ways of saying, hey, what would multiply by itself 4 times to give me that z? Going the other way, if I have a radical notation, whatever that index of that radical is, that will become the denominator of a fraction. So the fourth root of 81 is the same thing as 81 to the, it needs to be the denominator, so 1/4. And in both cases, we're trying to find the number that multiplies by itself 4 times to give us 81. I guess I must be really happy with the 3's today, because it's 3 again. 3 times 3 is 9, times 3 is 27, times another 3 is 81. So if I can simplify it, I will. But in the case of a letter, if this is radical notation, the index of the radical is 5. And so the rational exponent will be a 1/5. An example I wish I'd included in these notes actually would have been, what about just the square root of, say, x, when there's no index written? The default value there is going to be equal to 2. So in a situation like this, what I would do is take this x, and even though the 2 is not written, this does ask us what multiplies by itself 2 times to give us what's underneath, so I put that as a 1/2 power. So I did, not in your notes, but in the video, talk about it in class. Good luck.